Hello and welcome to the fifth video of our machine learning problem solving series. Imagine a neural network with just one neuron. No activation function, no deep layers. Just inputs, weights, and a prediction. That simple idea is called linear regression. And in this video, we'll understand how the forward pass works, how a model takes features and converts them into a prediction using weighted sums. By the end of this video, you'll understand the exact equation behind linear regression and how predictions are generated and why this becomes the foundation of almost every machine learning model. Now, what is linear regression? Linear regression is one of the most fundamental algorithms in machine learning. The idea is extremely simple. We take input features, multiply them by learned weights, add a bias term, and produce a continuous output. It looks something like this. You can think of this as the simplest possible neuron. Input goes in, weights scale their importance, everything gets summed together, and the result becomes the prediction. Unlike classification models, the output here is a real number. That's why linear regression is commonly used for price prediction, score estimation, trend forecasting, and continuous value prediction. And most importantly, it helps us understand the core mechanics of machine learning before moving to deep neural networks. Now let's understand the forward pass. The forward pass simply means how does the model compute a prediction? In matrix form, the equation becomes y equal to xw plus b. Here, x represents the input features, w represents the learned weights, and b is the bias term. If we only have a single feature, the equation becomes even simpler, which is y equals to wx plus 1 plus b, and b shifts the line upward or downward. Geometrically, linear regression is trying to fit the best possible line through the data. In higher dimensions, this becomes a hyperplane. The goal is always the same: make value prediction as close as possible to the real values. Let's look at an example. Suppose we want to predict the price of an Uber ride. The model receives three features: time of the day, ride distance, and trip duration. Each feature contributes differently to final prediction. For example, distance may have a strong positive effect, while time of day may influence search pricing. The model multiplies each feature by its weight, adds everything together, hits the bias, and outputs a single number, the predicted ride price. That's the entire forward pass. In real machine learning systems, we don't process one sample at a time. Instead, we process entire batches together using matrices. The feature matrix X contains all examples. Each row represents one training example, and each column represents one feature. The weight vector W stores the learned parameters. Then we compute predictions using matrix multiplication, which is y is equals to x times w plus b. This vectorized computation is what makes machine learning efficient on GPUs and large datasets. Instead of computing predictions one by one, we compute thousands or even millions simultaneously. Now, once the model makes predictions, we need a way to measure how wrong those predictions are. That's where mean squared error or MSE comes in. First, we compute the error, prediction minus actual value. Then we square the error. Why square it? Because negative and positive errors should not cancel each other out, and larger mistakes should be penalized more heavily. Finally, we average all square numbers. The formula becomes MSE equals to 1 upon n and summation of differences of predictions time squared. A smaller MSE means better prediction, and during training, the entire goal of the model is to reduce this loss. Let's begin with the implementation of linear regression. So, as you can see, here is the question description, and for the case of simplicity, they have mentioned that here we have to use y is equals to x times w. Here we are not considering bias, so that makes the question a bit simpler. Now let's begin implement it. So we are given two functions to implement. First is get model prediction, which takes x and w as the parameters, where w is the weights and x is the feature matrix. So let's begin. We will be using numpy array, numpy library here. So let's use matmul, which is used for matrix multiplication. And here we will use x times w. And since we have to return output round to 5 decimal places, so np.round and predictions 5. Now let's implement the getError function. Here we just have to calculate the error. So error would be equal to, let's first begin what the mean squared error was. So since the formula is like this, we will have to calculate what's inside the bracket. So inside the bracket, it was model prediction minus ground truth, and then we have to square it. So let's select this part, and here np dot square, and then see here the summation upon number of terms is nothing but the mean of what's inside the summation part. So here we will enclose this in brackets and write np dot mean. And since we have to round our answer to 5 decimal places, we will just use np dot round. So np dot round error and 5. Let's run our solution. So yeah, our 2 test cases have passed. Let's submit it. So yeah, our implementation is successful. Let's quickly summarize everything. Linear regression predicts continuous values using weights and bias. The forward pass is simply y equal to x times w plus b. Mean squared error measures how far predictions are from actual values. And this entire pipeline, prediction, error, calculation, and optimization, becomes the foundation of modern machine learning. So in the next video, we'll move to the linear regression training. So if you want to truly understand machine learning from first principles, make sure to continue with the next video. And if this helped you, don't forget to like, share, and subscribe. See you in the next one.